A very warm welcome to all my dear students. So, how are you all? Welcome to the T2O series of your favorite channel, You and I, with Dr. Ruchi Rai. So, today we have picked up some must revise topics for INICT. As you know, the exam is around the corner. So, few discussions, that means 2 3 episodes, will be towards INICT. The discussion would be all aimed towards INICT exams. Okay, so I'm picking up some very important topics which should be revised before the exam. Okay, let's start. So, coming to first this question. A 21-year-old boxer wanted to improve the vision. Which of the following surgeries indicated? What should you answer? These are all refractive surgeries. Are you all very, very clear about the basics of refractive surgery? What are we doing? Altering the curvature of the cornea. If I talk about the laser surgeries or the surgeries in the cornea, we are altering the curvature of the cornea. What is that called? Keratomyelitis. So, when we say altering the curvature, it should be absolutely clear to you all that more the curvature, more is the refractive power. M for M, more refractive power is what is myopia. So if I have to correct myopia, I have to lessen the curvature, flatten the center. If I have to correct hypermetropia, I will bulge the center, and so on. Also, for astigmatism, it has to be worked on one axis. The steeper axis has to be flattened. Correct? So this is how the refractive surgeries work. One by one, when you talk about boxer, which refractive surgery is recommended, let's first of all understand these four options. First is RK. Everybody knows it stands for radial keratotomy. Now it's obsolete, but you still have to know the surgery. What is radial keratotomy? If you look here, we leave the central optic zone of the cornea is left. Nothing is done here. Okay. And at the periphery of the cornea, as you can see, we are giving peripheral cuts with a diamond knife. 4 to 8 cuts are given. What happens? This becomes loose and it bulges. So when this bulges, what happens? The center is going to flatten, common sense. If the center flattens, that means RK is mainly used to correct myopia. So our radial keratotomy, we correct myopia. Okay, that is one. Second is PRK. What is PRK? Photorefractive keratectomy. Here, what we are doing, after giving the anesthetic eye drops, we are removing or debriding the epithelium. After debriding the epithelium, you put laser. Which laser are we talking about here? Excimer. Excimer laser argon fluoride. You should know this. It has been asked in your exam. It is 193 nm. The wavelength is 193 nm. Once you put the laser, alter the curvature, and then you bandage the eye, and later the epithelium will grow. So, because we are removing the epithelium, it can be a little painful, rehab time is longer, right? So, but what is very important and a major difference here, that we are dealing with superficial stroma. Okay. Then we talk about the next is your LASIK surgery. The third option, LASIK. What is LASIK? Laser in situ keratomyelitis. So we all know what we do here. After giving the anesthesia, we're raising a flap of the cornea. So when you're raising a flap, this has both epithelium and stroma. Okay? How do you raise it? It can be by a microkeratome, or we can do it with femto laser. When we do it with femto laser, we call it I-LASIK or Z-LASIK. So when you are raising this flap, remaining stroma, you put the laser here. This is what you're doing and sculpting the stroma. Later put the flap back. After that, the alteration of the curvature is done. Same excimer 193 nanometer. That is argon fluoride. But here we are dealing with and sculpting the deeper stroma. Keep in mind. What is the fourth option? Fourth option is SMILE procedure. What is SMILE? Let me show you. SMILE, what we do here is we are using femto laser. And in femto laser, what we do here, femto laser, what is the wavelength? 1054 nm. Let's remember this. Okay. So we focus directly on the stroma. There's no raising of the flap, directly on the stroma. Cut a piece of the lenticule. That piece is called lenticule, the piece of the stroma. And with a very small incision, you're taking it out. Again, we are dealing with the deeper stroma, but there is no flap. So Coming back to your question, in boxers, among all, what we should use? So see, first of all, RK, of course, it's a big no. Any contact sport, it can cause rupture. You're cutting the cornea and making it weak already. And again, I'm telling you, this is now obsolete. Second, we talk about is your was your PRK. Okay, let's leave PRK on one side. We talk about LASIK. Why LASIK is also discouraged, though it is one of the latest procedures with some refinements going on. Of course, more latest is SMILE. I'll correct myself. So LASIK again, because it's a flap surgery. So there's always a risk that with the contact sport, with the impact, there can be dislodgement of the flap. Therefore, this is also not encouraged in a patient, in a person who is playing contact sport. Okay, SMILE among all looks good, but still it is dealing with that deeper stroma cutting there. What is more recommended is why not to just stick to the surgeries which are dealing with superficial stroma. Okay, so surface ablation techniques are more encouraged in patient in the people who are playing who are doing playing boxing and other contact sports, okay, wrestling and so on. So you talk about surface ablation, of course, PRK is one, but PRK is also an older version. What we can do instead of removing the epithelium because it's painful and again you have to bandage, we raise the flap of epithelium, apply the laser, and put the flap back. This is what is called epiLASIK. But here our option has not been given on epiLASIK. So we are going to answer here, that is your PRK. This is indicated. Okay. Some of you have said, no, the question was which is contraindicated. And if it was a question as contraindicated, though I feel it should be indicated, then among all, of course, the best answer for contraindicate, this is also contraindicated, this is also contraindicated, this is also not encouraged so much because it is again not a surface ablation surgery. But among all, if you have to answer on contraindicated, we answer radial keratotomy. Correct? Okay, we come to another type of question, and that is must to revise is on Snellen's chart. So Snellen's chart should be absolutely clear, and what they've asked you is about the angles subtended at different lines. Let me make it very clear to you all before I go to the question. Let's solve the basic here. When in a Snellen's chart, you make a chart here. You have written these letters, correct? You're making the patient sit at 6 meters from this, and one eye closed, he's reading. Okay, you're right? Okay, what is very important? First basic that should be clear. What is normal? Denominator or numerator? You are going to say denominator is normal. Matlab, your patient is sitting at 6 meters, that is what is 6, numerator. Now, when I say 6 by 9, it means a normal person with a normal visual acuity can read this at 9 meters, which your patient can only read at 6 meters. When I say 6 by 18, again a normal person can read at 18 meters, but your patient is reading at 6. Got it? Now, how do you make a Snellen's chart? I just cannot just ask you, okay, sit at 6 meters, I write ABCD and I ask you to read. No, there's a scientific basis. What is that scientific basis? What angle is that letter subtending at the nodal point of the patient's eye? Do you all remember nodal point? Nodal point means the first focal point, the optical center of the eye. I'll just make it very simple for you all. So when the parallel light rays are falling, let me make it here. Yeah, no, it's okay. So when the parallel light rays are falling on the cornea, right? They are bent at the cornea, bent at the lens. They are not focused directly on the retina. First, they come and focus behind the lens. From here, when the light rays are focused on behind the lens, this is what is nodal point. Light rays will cross, and when the light rays cross, image gets inverted here. Now the same inverted image falls on the retina. The dotted line supposes the retina. It is our brain which will make it straight. So what is nodal point? Nodal point is the first focal point situated just behind the lens, or you can say the optical center of the eye. Now the angle subtended at the nodal point is the basis of making this Snellen. What is that basis? Every letter subtends an angle of 5 minutes, and the margin of the letter means if this is letter E overall is letter and is subtending 5 minutes, and margin of the letter is subtending 1 minute. Okay, where this angle is subtended at the nodal point of the patient's eye. Now you will be thinking, how is it possible? E is so big, last line is so small. How can it subtend the same angle? This is what is depicted here. What is different is the distance. So the biggest one is actually subtending this at the distance of 60 meters. Okay, this is subtending at a distance of 60 meters. Whereas similarly, when I say 6 by 6, the smallest, this is subtending at 6 meters. Okay, so what is changing is the distance. I hope you remember your physics, that the size of the image depends not only on the size of the object but distance of the object from the lens. So that is what we are discussing. Correct? Okay, so once we know this, we have to understand that suppose they ask you, okay, tell me E letter subtends an angle of 5 minutes and 1 minute at 60 meters. How much angle it is going to subtend at 6 meters where the patient is sitting? Then how will you solve? Any angle that is subtended, the simple method is you have to first calculate the minimum angle of resolution. Suppose I ask you for the line 6 by 60. Very simple, reverse the fraction. 60 by 6, this becomes 10 minutes. Life is easy. If I ask you 6 by 12, what is the minimum angle of resolution? Again, it becomes 12 upon 6, which is equal to 2 minutes, and so on. But this is minimum angle of resolution means this margin of the letter that is subtending. That is what is minimum angle of resolution. And what will be the overall? Overall, it is always 5 times. Okay, so it is the whole letter, it is made in such a way that it is always into 5. So overall for 60, it is into 5, which is equal to 50 minutes. Means this E letter is going to subtend an angle of 50 minutes at 6 meters. At 60 meters, it was 5 minutes. Got it? Similarly, if I talk about 6 by 12, now this 6 by 12 may all these letters D, H, L, N, E, D, H, L, E, N. This 6 by 12 is going to subtend an angle of minutes into 5. Okay. So 10 minutes, and this is the angle subtended in 6 by 12 at 6 meters. At 12 meters, it was 5 minutes. Okay, so this is the way we solve. If you come back to this question, it is very, very easy. Angle subtended by smallest letter in a person's eye who is reading a distance. So smallest is 6 by 6. So for 6 by 6, it has to be 5 minutes, and minimal, because minimum angle of resolution here will be 1 minute. Right? So this is another important question, a must to revise for NICT exam. We come to the next thing. Is this numerical? This should also be revised, how to calculate the amplitude of accommodation and so on. So with a near point of 10 centimeters, a hypermetrope of 5 diopters has to exercise accommodation of. So if this type of question comes to you, you have to go back to your basics, that any amplitude of accommodation, how much accommodation is exerted at the near point and exerted at the far. Near point is the nearest point where the patient can see clearly. Far point is the farthest point where the patient can see clearly. As simple as this. So naturally, as you go near, the accommodation is exerted more. Correct? So what is amplitude of accommodation? Power at the near point minus power at the far point. Near point is proximum, far point is remotum. So this becomes your amplitude of accommodation is power at the near point, that is proximum, and power at the far point, that is remotum. Now, once you know this, how do you solve this? The trick in this question is that he is an hypermetrope. Means, let's see. When you say near point of 10 centimeters, another equation that first of all, before we solve this, you should remember that any focal length is power is equal to inverse of focal length in meters or vice versa. Okay, so any power is equal to inverse of focal length in meters. If you are clear with these two things, you can solve this question. So when you say power is inverse of focal length in meters, 10 centimeters will become 100 upon 10, that is equal to 10 diopters. So that is the power at the near point. What about the far point? It is 5 diopters hypermetropia. So when there is a far point of 5 diopters hypermetropia, it's already given the power is 5 diopters. Should I just do 10 minus 5? No. So the trick in this question is hypermetropia. Do you all remember that the light rays are falling behind the retina? So far point of hyperopic eye is always behind the retina. Because it is behind the retina, therefore it is taken as minus. So 10 diopters is the near point, minus 5 taken. So actually it becomes, use your algebra, 15 diopters. Okay, so this is how we say. Had this patient be a myope, we will just say 10 minus 5. But he's a hypermetrop, so it becomes 10 minus minus 5. That is the trick you have to keep in mind in solving these questions. Okay, come to the next one. Next one is your another question which is where must to be revised. Actually, it should be revised for both the exams, of course, INICT and NEET PG. And what is this? Is the type of astigmatism. I hope you all are very, very clear what is against the rule and what is with the rule. So first of all, against with the rule ka matlab, if this is the cornea, curvature is more of the vertical. When this is more curved than horizontal, this is called with the rule. You know why do you name it like with the rule? Because normally due to the pressure of our upper lids, a little bit pressure, of course not too mildly, our vertical curvature is anyway little more than horizontal. Even if you are e-metro, it may be insignificant. So yeah, it is following the rule. So when it is too much, but still it is the vertical which is more, we call it with the rule. And what is against the rule? If you talk about against the rule, this time it is reverse. Horizontal is more than vertical. When horizontal is more here, now you call it against the rule. Okay, then we talk about the type, other way of classifying, which is asked just this. So when I say simple myopic, do you understand this? One from one meridian, vertical and horizontal, if you take, is focused in front of the retina, from the other on the retina. This is simple myopic. If I write retinoscopically, I can write simple myopic as minus and zero. One axis emmetrope, another axis, minus. That is myopic. Simple hypometropic means one focusing is behind the retina, one is on the retina. So either one is, and either axis can be emmetrope and one will be your plus. When I say compound myopic, both axes, the focusing is in front of the retina, as you can see here. And therefore, I indicated both minus, but different, minus 2, minus 3, anything. And when I say compound hypermetropic, this time both are plus. Mix means one is in front, one is behind, one is plus, one is minus. This is how you classify. Once you know this, we go back to the question, minus 3 diopter spherical, minus 2 cylinder at 180. You have to answer this, don't answer so quickly. Very systematically, we make two lines and first convert it into retinoscopic reading. Minus 3 spherical means here is 3, here is 3. What is the trick here? You all should know when you write it in a prescription, this is mentioned opposite. So when I say minus 2 at 180 degrees, power must be at 90 degrees. So minus 2 will come here. Okay? So this is the basic that should be very, very clear to you regarding retinoscopy. And if this is so, now what is the power here? Minus 5, minus 3. So is it against the rule or with the rule? After solving everything, many students, what will they do? They will answer wrong because they are not clear what is more power, what is less. Minus here on a retinoscopic reading is only indicating myopia. Plus is indicating hypermetropia. When you say minus 5, myopia is more power. Minus 5, what is 0? Emmetropia. 0 emmetropia, what is the power of the eye? 60. So this is a simple method. You will never forget that when you say minus 5, it means the power on the vertical axis becomes emmetropia mein. Emmetropia is 60 plus 5 more, 65. Whereas minus 3 means 60 plus 3, 63. So more power at the vertical. This is with the rule astigmatism. Yeah. Now, if you want to think vice versa, you can. Suppose, for example, this is just an example not related to the question. I'm just saying, suppose this was plus 5, this is plus 2. Now is it with the rule or against the rule? Plus hypermetropia, less power. This time it is actual part, emetropia is 60, plus 5 means minus 5 is the part. When I say plus 2, actually it is 60 minus 2. So now the part is more in the horizontal. So this becomes against the rule astigmatic. Remember, 0 is 60 diopters, minus you have to add, plus you have to subtract. Right? I hope this is clear to you now. Right? So this was all for today. Please revise all these types of questions and these topics for your exam. Thank you so much. Stay blessed and keep smiling.